Good evening, and welcome to the inaugural lecture in the Leadership Lecture Series. This is a series of talks that we are hoping to bring you, where we are going to try and get some esteemed alumni from our ranks who happen to be leaders in their industries, in their work, thought leaders as well, and so they're not necessarily going to talk about the business that they're running, but rather some learnings that they have acquired during their professional careers, which we think will also be of great benefit to students in terms of helping guide their actions. Some of these talks will be more technically oriented, and I'm sure the faculty will benefit greatly as well. Today's talk by Dr. V. Sumantran, is on corporate cultures and innovation. Sumantran has had a very distinguished career, but I really think that the high point of his life came when he graduated from IIT Madras as part of the renowned 1981 batch, which is a vintage that has never been matched before or since, as all the experts claim. But since his BTech at IIT Madras, he has done MS and PhD in aerospace from Princeton University and Virginia Tech, respectively. And he also has a master's degree in management of technology from Rensselaer Polytechnic. He is currently Executive Vice Chairman of Hinduja Automotive UK, and he leads the group's expansion strategy, including sectors such as light commercial vehicles, construction equipment, IT, defense, aerospace, and technologies. He is a member of the board of Ashok Leyland Limited and Chairman Ashok Leyland Nissan Limited, Chairman Ashok Leyland John Deere Limited, and Chairman Ashok Leyland Defense Systems Limited. He is also Chairman of Defiance Technologies Limited, an IT and engineering consultancy, and he is Chairman of Albonair, an emission technology company based in Germany. He serves on the Scientific Advisory Committee to the Cabinet of the Indian government. He also served on the Science Advisory Council of the Prime Minister of India. He is a member of the National Manufacturing Competitiveness Council. He is a member of the Global Technology Council of John Deere US, and he serves on the Group Advisory Council of the GMR Group, one of India's largest infrastructure enterprises. He is also a distinguished visiting professor at the Indian Institute of Technology, Madras. From 2001 till end of 2005, he was the chief executive of Tata Motors car business. During this period, he basically innovated the nano low-cost and area high-end car projects. He was a member of the board of Tata Cummins Limited, a joint powertrain company. He was also chairman of Concord Motors, an OEM-owned automotive dealer network. He served as president of the Automotive Research Association of India, chaired the Engineering Services Forum of NASSCOM. He also served as president of Society of Indian Automotive Manufacturers, and is chairman of the CII Chennai Aeropark Advisory Board. Before joining the Tatas, Dr. Sumantran had a 16-year career with General Motors in their R&D center in Detroit. So Sumantran is with us, and I invite him to come and give his lecture. I also request Professor Bhaskar Ramurthy to hand him a bouquet.
Good evening, ladies and gentlemen. It's great to be back in these wonderful grounds again. I have chosen to talk about a subject that I must start with a preface upon. These days there's a lot of talk of innovation. I think sometimes I think too much of it. In fact, these days when I tell my wife that, oh, by the way, I have to prepare for a talk, and she says, oh, please don't tell me it's one more of those innovation talks. So it does get jaded sometimes. But perhaps more to share with you, not so much this jargon about innovation, but really the experiences, the inspiration, And the kind of, this is perhaps more of a storytelling than it is any talk about innovation. And obviously this is based on personal observations. I do on other occasions when I'm on the lecture circuit have a talk that is more about generalized ideas about innovation. But frankly, to me, what is important is where it's been personal and where it has been possible to build upon something. So these are just, this is a bit of storytelling, and this is in a way almost chronologically what I've seen through in my working career. Next slide. You know, obviously I started my career as an aerospace engineer. I graduated with degrees in aerospace engineering. It just so happens that my other love was cars and motorcycles, so I ended up spending all my career in the other field. But this was an association very early in my working career that I really enjoyed. The person you see there featured is Paul MacCready. Paul MacCready is a real genius in the field of aerospace engineering. He was a professor at Caltech. He was, among other things, a world record holder for sailplanes, and most importantly, he's the person who designed the aircraft that you see here. This is the Gossamer Condor, the first human-powered aircraft to cross the English Channel. And what you see there in the gondola is a bicyclist who's pedaling, and it's this, that power that is transmitted to a propeller that is the sole motive force for this aircraft. And they were the ones who successfully flew across the English Channel with nothing but human power. The reason I start with this slide is obviously this is a great feat of innovation. That aircraft, for those of you who are from an aerospace background here, that aircraft that you see there has the wingspan of a 737 and weighs 32 kilograms. And I remember talking to Paul. By the way, Paul and I happened to work together on a different project. In fact, he and I own the world land speed record for the fastest wheelchair. And by the way, the speed record for the fastest wheelchair is 68 kilometers per hour. So during that project, we were talking to Paul, and I was, obviously as an aerospace engineer, I was marveling at this design, and I said, you know, what a fantastic design. It must have been truly a difficult challenge to overcome. Paul is a typical curmudgeon. He is a crusty old Californian. And he dismissed what I said by saying, no, we should have done better. It was actually over-designed. And I said, what do you mean it was over-designed? 32 kilograms, and you got the wingspan of a 737. And I said, how can you over-engineer this? And he said, no, we had designed the structure so that it would sustain at least 7 takeoffs and landings, because we knew it wouldn't fly on the first occasion. But finally, by the time we really flew across the English Channel, it was the 13th takeoff. So obviously, the aircraft was over-engineered. This, to me, was a phenomenal lesson. I mean, how many of you used the term factor of safety? Yeah. Factor of safety is that huge domain of uncertainty where we brush things that we have an inability to either predict or control or manage to the degree that we would like to. Obviously, in an aircraft like this, a larger cushion, a larger factor of safety would have made the difference between a successful mission and an unsuccessful mission. And so this taught me, first, this pursuit of excellence to say, you know, we can't leave things mostly done, that we have to chip away at all the remaining elements. Now, the same concept you could think of, the Japanese have this concept called muda. Muda is waste. The whole concept of Japanese productivity is all related to elimination of muda, or waste on the factory floor. Wasted motion, wasted material, wasted effort is all muda. And I often wonder how designs that we have in the world today would bear themselves up to the kind of scrutiny that you would need for the concept of muda in design. What is muda in design, and what is waste in design? I think this was for me a very, very early learning. It was a learning about mindset. It was a learning about the art of possible. Indeed, the art of possible if we really challenge ourselves. Next slide. Another, subsequently, and again, as I said, this is chronological. Already you can tell now that I moved from aerospace into aerodynamics of cars. This was a time, again, at General Motors where I had a very, very innovative colleague. I use the word innovative very guardedly because there are truly very few innovative people. But this person certainly qualified and earned that label. And we were obsessed with all kinds of methods of prediction. These were early in the years of computational fluid dynamics. In fact, our group at GM Research funded Professor Gossman at Imperial College for the first general purpose hexahedral volumetric Navier-Stokes code with a turbulence model, which subsequently became star CD. So those of you who are familiar with CFD and you use the commercial code star CFD, star CD, star CD came out of our early investments in the 80s into this domain. Now, obviously, this is a brute force method of having a million cells and a huge amount of boundary conditions and churning this on a Cray supercomputer for God knows how many hours, and then you get out results. But there was this colleague of mine, this brilliant, innovative Greek scientist, who started to experiment with the combination of geometry, neural networks, and knowledge database. And over time, we built up a huge database of just every possible car and car configuration that General Motors had developed. And with appropriate parameterization, was able to start to build neural networks that would react to very simple prescriptions of geometry and literally with minimized data. You know, a car picture that you see like this would probably have 5 billion cells, but something that would have 10,000 surface cells of description of geometry, and to be able to dynamically perturb that surface. And because you were not any longer linking the result or the computation to computed result, but rather estimates through a neural network system, you could have almost dynamic and almost instantaneous response to geometries and shape changes from aerodynamics. Now, this was nice to be thought of as an academic exercise, but the car that you see on the right there, this was a car that GM built under the umbrella of the PNGV concept that Vice President Al Gore had promoted with the US government. And the idea was, can you take an average American car and increase the fuel efficiency threefold? So that was 3x fuel economy, which meant that this car should achieve 81 miles per gallon under the standard driving conditions compared to an average car that would, say, achieve about 27 miles per gallon. Now, this car, that entire shape development was guided by the system. And the remarkable innovation about the system was it dispelled with all of the very complicated, expensive computations and gave us what I would say the first 80% of the shape with very, very limited effort and an opportunity to iterate very rapidly through a larger number of surfaces. And I think this went back to his conviction. First of all, this was very, very carefully parameterized. I will not trivialize the amount of work that went into this. But it was this view that I can get a very good estimate of drag coefficients based on a well-trained database, a very intelligently parameterized geometry, and very, very minimal, literally algebraic operations. And it resulted, this car ended up today as a production car, it has the lowest drag coefficient of any production car in the world. It has a drag coefficient of 0.168, which for a fully functional family car has not been achieved since then or till date. Subsequently, one of the nice things that I enjoyed at GM Research was, in those days, GM Research was the mechanical equivalent of Bell Labs. We had a phenomenally liberal and a very, very far-sighted VP of R&D, one Dr. Bob Frosch, who was a very eminent researcher. He was a member of President Carter's Council of Scientific Advisors. He was a former administrator of NASA. So we were really privileged to work in an environment where he believed that his own philosophy to R&D was, you hire the best people and you let them swim, in his words, in a sea of ideas, and you kind of do whatever you want. And there were a bunch of guys in the neighboring department who came to me one day and said, hey, you got the fluids guys. Tell me, we're dealing with this kind of fluid where there are suspended metal particles. And over time, I began to understand what they were trying to do. And really, what they were trying to work with was what is now called the MRF fluid properties. MRF stands for magnetorheological fluids. Magnetorheological fluids really are fluids where viscosity can be changed based on the application of a magnetic field. So you can imagine in that cylinder there that it is filled with this fluid, and the application of a magnetic field would determine the viscosity of the fluid. Now, this has huge implications. If we really think about where do we use viscosity, frankly, even the door closer here at the door to this auditorium uses fluids for damping and for using the viscosity properties of fluids. And they got quite far in actually doing this, to the point where they started to use it for shock absorbers and dampers. Now, if you're driving a car out in the streets today, you probably want a car with relatively low damping. You got very bad streets, very bad road surfaces, large displacements, and you want to be able to damp it, but you want to allow sufficient displacement to be able to manage it. And yet, if you were to be on a racetrack, you want a car that has very limited, very stiff ride characteristics, so that predictability and the stiffness in roll and stiffness in cornering performance is managed. And so today, frankly, the car that you see, the lovely Ferrari, actually has a damper that is built out of this pattern, where they use magnetorheological fluids so that when you're driving this Ferrari in the city streets, whether it is the cobblestones of Milan or whether it is the racetracks of Europe, it is able to dynamically adjust the level of damping through this. And by the way, the nice thing about this is it's almost instantaneous. There's no valving, there's no changes, there's no physical movement. It literally reacts instantaneously to the application of the magnetic field. And this is a phenomenal example today of how, in the span of 15 years, something went from some sort of idea to a practical product available for sale in consumer products today. Just go back one. No, next. Stop. I then had the good fortune of moving to Sweden. Towards the end of my career with GM, I spent 3 years in Sweden, where I was the head of engineering for Saab, the Swedish car company, which was 100% subsidiary of GM. And I was, as head of engineering there, we were grappling with the kinds of products and features that European technologists were looking at, and European premium car products were looking at. And one of the things that we were worried about was this concept of whiplash injury. You know, you can imagine all cars have these head restraints, but if they are not well positioned, you used to find a large incidence of whiplash injuries to the spinal column or to the neck vertebrae. Because if you imagine you are on a traffic light and somebody behind you doesn't see you and he comes and hits you from the back, your head is jerked back in the dynamics of the crash. And very often you will have injury to your spine or to your neck. And this is something that automakers were really trying to avoid. We found we were talking to a number of suppliers and we got ideas about things like the lower design. It's a head restraint that will be projected forward. It will move forward with displacement based on very fast acting servo motors. There were others who came up with designs that would have literally an airbag inside the head restraint which would deploy when it sensed a very large G load. And that head airbag would deploy and catch your neck. So we came up with a lot of different options, ways to address this kind of an issue. As I said, this time I was in Sweden. And again, you know, those of you who have had a chance to work with Swedes, they're a remarkable race of people. Very pragmatic, very low-key, not given to flash, not given to showmanship. And there is a very quiet utility, a quiet puritanical efficiency about the way they go about things. And so we were talking about all this, and these guys said, you know, this is all nuts. You know, it's too complex, too many electronics, pyrotechnics, motors, sensors. Surely there's a better way to do this. And sure enough, one of the guys in my team, actually a guy and a girl together, they came about with a very nice idea. Next slide. They studied the occupant dynamics during a crash and said, no matter what happens in a crash, the first impact is to your lower back. And your lower back gets pressed against the seat. And if we can use that energy, surely we can do something about it. And finally, what they ended up was this beautiful system of a lever. In this case, there's nothing more than a lever that is buried inside your seat back, which will react to the pressure that is very natural in the case of a crash, and that lever automatically moves the headrest forward and catches your neck. The brilliant simplicity about this was there was no electronics, no sensors, no pyrotechnics, nothing to reset, and this was fail-safe. And by the way, today, any Mercedes, any Audi, any BMW, any Saab, any Volvo that you have that has an active head restraint system uses this patent. And here again, this was this culture issue. You know, I'm sure if this was an electronics company, we would have found everything possible to wrap this with electronics to make this work. If this was an airbag company, we would have put in all the fast pyrotechnics and fast-acting gas firing to be able to deploy airbags so fast. But the culture of saying, you know, let's keep it simple. Is there a better way to do it? Is there a more elegant engineering way to do it? I don't think this could have happened in the US. It happened in a culture where there is value associated with simplicity and very simple, plain efficiency. And I think it was, for me, a remarkable eye-opener on how you could look at problems differently and be persuaded that engineering simplicity has unique charm and unique value. Order. This is a simple lever device. It just reacts to a physical load. I can't remember. I'll have to go back many years. Another thing about innovation has to do with networking. You know, innovation clearly thrives when we're able to spark ideas off each other. In fact, I would say in India, we suffer from a lack of mobility between industry engineers interacting with academia, academia involved in industry, research labs interacting with problems of science and technology. I think, and there was a very interesting experience that I went through, and I think I narrated this to Professor Bhaskar just before we came here. There was a time that under the auspices of CAR, the Core Group for Automotive Research, the Government of India was trying to bring, to fund innovation and technologies and technology development across the spectrum of universities, national labs, research institutions, as long as they were aimed at problems that were related to problems the auto industry wanted to solve. And we found that there was a particular conference that we had with the audience of NASSCOM, where we had two rooms of people. In one room, there was a bunch of automotive engineers talking about the noise testing problems that they had. In fact, there was the head of TVS Motors, who make all the motorcycles and two-wheelers here. And they were talking about the quality control they had for engine noise, and how there was a guy, a very experienced old guy, who was determining whether that engine had slight amount of tappet noise and therefore had to be reworked at the end of the assembly line. So he'd say, this engine's got tappet noise, this engine's got gear whine, and all the other engines are okay, and this was the quality system. And they said it was difficult to bring that subjective understanding. In another room, there was a professor from IIT Kanpur who was talking about fast Fourier transforms, signal processing, signal decomposition, and so on. And it turned out that, frankly, the problem that one was stating to be solved was exactly what the other person in the other room could solve, except they were talking completely different language. One person was talking about Fourier transforms, and I don't think the guy in the industry understood what he was doing. The other guy, the professor, was talking about how he could separate the voices of Lata Mangeshkar and Mohammad Rafi from a single track, and this guy said, what industrial value is that? But actually, you had to put the two together and say, this is what you're looking for. And I'm very happy to say that this was what was done. And today, believe it or not, whether it's TVS Motors or Bajaj Auto, through this Government of India forum, this connection was made, and today, with nothing more than a simple microphone, an A to D device, laptop processing, one is able to run a very systematic noise signature analysis at the end of the final engine test area for both Bajaj as well as TVS. And with this, obviously, you can do a lot more about noise characterization and look for drift in the desired spectrum and so on. But this was something that only happened because we were able to bring people together. I think our culture, I know how difficult it is. I spend a fair amount of time in Delhi with some of our Department of Science and Technology or our TIFAC or other functions. And I know how difficult it is today for us to look for mobility. Somebody from IISc can't suddenly give up 2 semesters, come and work at IIT Madras. There's a whole bunch of complicated issues. However, when we're able to promote mobility, getting dissimilar people to talk to each other, industry and academia, for instance, all of a sudden, as we start to develop language that we can understand each other with, I think there's going to be a huge ability to create innovation, because in India, without a doubt, we have a huge amount of capability of solving problems. And God knows we have enough problems to solve. It's a question of bringing together the right people with the right language, and to really, in the analogy of a combustion chamber, bring them together and provide the spark, and then all kinds of things can happen. And I think innovation requires this kind of mixing and mobility of people. Next slide. Very often, constraints are the biggest motivator. Nothing, and this is great for India. We have so many constraints. We must be the biggest innovators. This was when, towards the latter part of my tenure at Tata, we had the ambition to build what is called a crash test laboratory. And in this, you see the car that's rolled over. And the idea is to drive a car very fast on the ramp that you see on the right, and deliberately let the car roll over, And the idea is then that you look at the occupant dynamics, you look at the structure, you look at how the deformation happened. Typically when the car goes over, the right windshield gets hit first. How much does it deform? Does it injure the passengers inside? And all of this is done in a very, very highly illuminated area, because this is subject to very fast photography. So literally 10,000 frames per second. And so you've got to have a lot of illumination to be able to capture literally millisecond by millisecond evolution of the crash. And by the way, this is a nice European crash test facility. This is what we wanted to have in Tata Motors. And so I signed all the capital appropriations for a rollover test facility, and our guys went about trying to set it up. And then within 2 months, they came back to me and said, sir, you know, this is crazy. The light banks alone from the suppliers, both GE and Siemens Osram, the light banks cost more than our total appropriations. We can't afford this. So I said, you know, then we'll have to wait for a couple of years, because I can't allocate more money. We've got so many other things to allocate money. But surely there must be a better way. Why don't you go and look for it? And again, this constraint that we couldn't afford to do it the conventional way got guys thinking about it. And then, long story short, they got this whole facility built. Next slide. There was one of the guys here who had a friend who worked in the Bollywood studios. And he said, you know what, in Bollywood studios, they use a lot of very high power lighting. And it looks like the spectral content of that light is adequate for us to be able to use it for our application. And sure enough, long story short, today the Tata Motors crash test facility is operating. It was funded within the appropriations budget that we had. And the entire light banks was jerry-rigged with lights borrowed or bought from the Bollywood studios. And as a result, we were able to achieve what we wanted. And frankly, I'm sure if we had the money, we would have wrote a big check to GE or to Siemens, and we would have got a big light bank. But our engineers, when you box them in and say, you know, I got a constraint, I don't have budget to do it, but I still want to do it, and they're passionate about doing it, you find all kinds of things can be done. Now, this is not a great scientific breakthrough, but this is more a matter of getting the job done within the constraints imposed. When you have the, shall we say, the fire to say, I must get it done, I want to get it done. This is coming from the fire that people have to say, I can't let this job go. And this we have a lot of in India. In fact, our culture is a beautiful crucible for solving problems like this, because in India we are resource constrained. But rather than complain about it, let's think of that as an advantage and say, down the road, we know the whole world is going to look at conserving resources. The whole world is going to look at conserving energy. We are growing up in the crucible which encourages solutions with frugal solutions, with energy efficient solutions, and therefore I hope we are endowed with an advantage to solve these kinds of problems, which for the next 50 years for the world will become very, very valuable skills. And I hope we in industry, in academia, take this on as a delightful challenge to say, because of this, you know, maybe we're going to be the path breakers in the next 50 years for global solutions. Of course, a lot of this kind of stuff went into the nano. I won't go into the details. I won't bore you with all the details. But we literally had to rethink the whole structure, whether it was the body in white structure. By the way, even compared to the lightest car in India, the Maruti Suzuki Alto, the Nano is about 20% lighter and offers about 30% more interior space. So a lot of very innovative packaging, layout of the structure. The idea that we had a corrugated roof allowed us to go to a thinner gauge of sheet metal in the roof. The idea that we had a cross-car beam tying the two B pillars allowed us to have less weight in the structure while achieving the same structural rigidity and torsional performance. So a lot of ideas that went into this. Half of it is kind of blind. Most users will never understand what is there behind it. But it was again an environment of constraints to say, I don't have more than so much money, I don't have more than so much budget, and yet we got to get the job done. Next slide. Now this was true not only for us, but also for our supply chain. When we were talking to people initially about, at the Auto Expo, you will soon now see the first diesel nano. And when we were first looking at the common rail diesel system, the terminology now is becoming mainstream. When you look at the common rail diesel system in the industry, we found that the cost of it was about 800 euros, even for a relatively simple system. But we worked in this case with the supplier Bosch, and we kept on talking about the constraints, the problems, the challenges on cost. And as a result, the nano system will cost roughly about 200 euros. And if you look at the specs, it's a combination of appropriate feature content, fairly advanced electronics, and a very, very tight cost-oriented performance. And they are both Euro 4 common rail diesel systems. Next slide. Which led to, leaders in this industry. Both of them I know very well. Carlos Ghosn is the chairman of our joint venture partner Nissan, and Ben Bohr is the chairman of Bosch, the person who was responsible for leading the company's common rail development shown in the previous slide. But if I just read one of those, Carlos Ghosn says, frugal engineering is achieving more with fewer resources. The cost of developing a product in the West is high since engineers there use more expensive tools. In India, they achieve a lot more with fewer resources. Now, this is to me a phenomenal virtue that we are learning in India. Our environment, our culture orients us to solving problems more frugally, and I think in the long term this will have huge ramifications on how we may be a bigger innovator in the global landscape. Next slide. Now in our group, we are doing a lot of this. I think in the central picture you can see some of the newer trucks and buses that are part of the group. The defense sector that we have grown quite significantly in the last few years. Our joint ventures with Nissan and John Deere in the areas of light commercial vehicles and construction equipment. Our acquisitions overseas with the Avia, which is a Czech truck maker based in Prague, and Optare, which is a UK bus maker based in Leeds. And for the future, we have invested in 3 areas on the right: on automotive electronics, on emission systems, and on IT and enterprise and knowledge systems. Next slide. And so if you look at the most recent offering from our Nissan joint venture, unlike other occasions where we might have been tempted to go to Nissan and say, do you have an engine for this vehicle? We actually went ahead and designed from clean sheet a brand new Euro 4 common rail diesel. You see picture on the right. It's a 1.5 liter 3-cylinder, completely designed and developed in India, and developed to a completely new cost point. In fact, Nissan jokes that globally they couldn't get an engine of this size, of this performance, anywhere in the world for less than at least 20–30% more cost. So our guys have done a brilliant job of creating a modern engine, but a very, very cost-competitive engine. And this was done at our joint venture along with help from Ashok Leyland and Defiance, our IT company. Next. Similarly, given the growing role of electronics in vehicles, we formed a joint venture with Continental. In the future, you will find that trucks like this, our G91 truck here, a U truck, they will have onboard systems. In fact, this truck has this box on the right that you see. And this is a telematics box, so basically like an aircraft, it's communicating data back to the base. And it's not just GPS information about location. It's about speed, about the engine, it's about how the driver is using it, it's about the throttle position, about the braking, about the coolant temperature, about the oil temperature. A whole bunch of parameters are being constantly streamed back. So similar to those of you who are Formula One fans, when you see the race, you see the team engineers at the pit wall, and they're looking at banks of laptops with data coming. And so they know, in fact, yesterday's race, somebody relayed the news to Vettel to say, you got a problem with second gear, save second gear, short shift. Now this is because that data is coming telematics and streaming back to the data banks in the pits, and they're able to look at the temperature, they're able to look at the speeds, and they're able to relay information back. Well, this is not far from this, that you can actually today get data that is streaming back to the base for various vehicle parameters, and from that you can literally manage the fleet, manage the vehicle, manage the operations. And more importantly, when we first started to look at what we could get from the European supplier, again we found we couldn't afford it. But in our joint venture with Conti, this unit on the right has been developed with Indian engineers in our Indian joint venture. As you can see, the specs are even more comprehensive, and more importantly, it's at a far more attractive price. And finally, we felt that we needed to invest in the clean air technologies, that as we go to the future, we will have to reduce emissions from the tailpipe. So whether it is particulate matter, whether it is NOx, whether it is hydrocarbons. And you can see from Euro 0 to Euro 4, you can see the size of the rectangle going from the red zone to the blue zone, to the light blue zone, to the green zone, and to the dark green zone. This is the envelope that demonstrates the degree of reduction of exhaust emissions in modern vehicles. And to do this, we founded a company of our own, a 100% owned company in Germany, that makes the entire set of systems designed for NOx emissions. And here again, they've developed a very interesting SCR, selective catalytic reduction system, which has an air-assisted injector of urea, and as a result achieves far greater conversion efficiency and at much lower cost compared to the typical European systems. You know, at the end of the day, I think innovation is all about thinking a little differently, using the constraints that you have and being willing to look for that other way of doing it. And I'm a great fan of this American poet Robert Frost, and I always like this. He says, "Two roads diverged in a wood, and I took the one less traveled by, and that's made all the difference." Thank you.
Economic and social problems as well, as much as it applies to technology. Is there sufficient push towards that? Because if you look at the world today, India is looking at whether you should bring in FDI from something which is copied from the society, capitalist society that has failed almost. There is a Eurozone crisis going on. The economy of America is in shambles, and Japan is down now. So all this, the challenges that we face today as a human race is more in terms of what is the innovation in the social setup that we have? What is the innovation that we can have in economic, the way forward? The world over, Syria, Libya, Iraq, Afghanistan, Algeria, Morocco, Yemen, Kuwait. I mean, all of these are burning issues and burning problems. So innovation as you said, is a very big buzzword these days, but if it be only applied to technology, then I think we are missing maybe it's the other road that we have to take. So if you can just comment on that.
I'll comment on it in two parts. One is innovation, whether it is to an economic policy, application of ideas for incentivizing the economy, whatever. Innovation is, at the end of the day, and I'll never try to define innovation. It's very complex. However, we all know the building blocks. One is service to society. Nothing can be called innovative unless there is value to society. And the other part of innovation, whether it is in the field of economics, whether it is in the field of technology or environment, the other part of innovation is being able to go beyond what is done day to day today. Therefore, it is thinking a little differently. So to that extent, whether it is networking, whether it is the cultural influences on innovation, again, if I go back to the way Swedes would solve their economic problems, the way Swedes solve their economic problems are indeed derived from their culture and their way of thinking. So I would say broadly, there is room for culture influencing the way we innovate, whether it is to solve a social problem, an environmental problem, an economic problem, or a technological problem. The second, I will take refuge in the very simple defense that this is my dharma. I am at the Indian Institute of Technology. I've spent all my life in engineering. This is my dharma. I am not an economist and I'm not a social scientist. So I cannot speak authoritatively, and I will claim relative ignorance on how this can actually be deployed in the fields you mentioned.
You rightly mentioned the innovation is related to the culture, the environment where the innovation is taking place. I'm just reminded of, just saw your slide on the OBU unit, what you said. It's very good, and I'm slightly related to this area. See, in Indian context, the long-term transportation, goods transportation, the problem of fuel theft is quite common. Now, when we design an OBU, the innovator, designer should think how to remotely monitor the fuel levels also along with whatever he is doing, so that there is a cultural, that theft, how to prevent the thefts. So the driver or the cleaner should not steal the fuel on the way. There should be a monitoring remote unattended by these people. So what I'm saying is the environment, social environment, has an impact of what innovator is doing to solve the problems, which is your comments.
Actually, it's interesting you mention it, because that particular problem is something that we have been working on for 3 years. We have had sensor-based measurement, including the rate of depletion, because in any case, the sensor, the fuel tank level will change. The question is, rate of change is the indicator of pilferage. We have looked at sealing systems, we've looked at, but I must admit defeat, because the perpetrators of this have been one step ahead of us in innovating how they will pilfer. And honestly, we have got very expensive solutions to try to combat this issue. But frankly, I've almost thrown up my hands in defeat at their ability to innovate.
How do you institutionalize innovation? I mean, companies are all trying, everybody is trying, right? And how do you teach it? This second question, how do you teach it in a place like IIT? How do you do that?
I think this is one of those things that I believe the inventive spirit, the innovative spirit obviously benefits from the duality of nature and nurture. I think there are some people who are predisposed to being less brave, less adventurous, less daring, and there are others who are predisposed to this, and there is some, therefore, predisposition to innovation, but therefore it is a combination of nature and nurture. Having said that, I can definitely believe that there are many ways one can mold the climate to make it more conducive for innovation, starting with, as I said, freedom of thought. I think I like this book by Amartya Sen, The Argumentative Indian. By nature, Indians are rebellious. We refuse to conform. We are individualists, and in many ways, similar to Americans, we like to think for ourselves. We don't like others thinking for us, which is quite often not the same in other cultures. There are other cultures that are conducive to being molded, shaped. I think Indians by nature rebel. So I think this is a good trait to start with. The second is, I think a lot of this has to come from the kind of time we allow for ourselves. In fact, I would say today, industries, organizations are making it more difficult for innovation. The same Paul McCready that I showed you in the earlier slide, another part of the same discussion, I was walking him from the main building auditorium in GM Research through the various hallways and corridors, and I was actually walking out with him for lunch. And as he was walking, he was just looking through the glass doors and looking at people working, and he just turned around to me and says, there can't be a lot of innovation going around here. So I said, again, as I said, Paul is a crusty old fellow. So I said, why do you say that, Paul? And he said, well, I can't see anybody staring out of the window. Everybody's looking at the computers and they're working. There can't be much innovation. You know, I think it's true. The mind needs space. We need time. We need the freedom to open out and imagine. Dreaming is a very big part of innovation. If we don't have the time to dream, apart from the courage to dream, I think we will constrain innovation. So there are a lot of things that, and frankly, that way IIT has enough, greenery and pastures. I think you've got a great environment for dreaming. But I think it's important that we're able to mold this within cultures. And then, of course, it goes into the culture that we were talking about, thinking simple, thinking constrained. All these are cultural, but last but not least, the fire in the belly to win. The fire in the belly. I mean, at the end of the day, if there's anything we can learn about Steve Jobs and the brilliant innovator we lost, it's that he never would quit. And I think, how can we encourage our people to have that fire and that conviction?
Spoke about innovation, spoke about examples of. You spoke about the examples of Tata Motors and Nano. And while we have been innovative, was there any risk at any point in time on compromising on quality?
The honest answer to this is solving an engineering problem is solving a problem of constraints, because you've got a mobility constraint, you've got a cost constraint, you've got a manufacturability constraint, you've got a safety constraint, and design points. If I now speak in the abstract about points in design space, points in design space are optimized based on how you move these various needles on cost, safety, performance, manufacturability, and so on. I think to the extent that we had defined what this vehicle should be, we felt that we had achieved the objectives. For example, even this Nano has what's called side intrusion beams in the doors, so that if the car is ever subjected to a side impact, that there are stiffeners in the door beams that will actually protect the occupant. It's not just the sheet metal of the door. There are actually door intrusion side beams to provide additional safety. Similarly, the vehicle would pass the standard European crash tests, so that things like the steering column intrusion were all protected. But if you ask me, would it be as safe as a Mercedes or an Audi? No, clearly not. But we also looked at, the picture that we all had, honestly, which is, I know it has been part of the folklore with Mr. Ratan Tata, and this is true. The picture we had was a man and his wife and 2 kids riding on a scooter. And our objective was, how do we afford, or how do we provide affordable mobility to that person so that he can keep his family away from harm's way, or for that matter from the environment when they are traveling. Now, I think whether we could have done better on cost or safety, well, within the constraints of the problem, we think we could not have. But there's always another person who might have a different set of values or a different set of priorities for whatever would be a point in design space. Okay, well, thank you very much. It's been a pleasure sharing this with you.
Let's, again, I want to thank Sumantran for coming and delivering this marvelous lecture. I would like to request one of our alumni, D. Chandrasekhar, Secretary of the Alumni Charitable Trust, to present a memento to Sumantran. The reason I'm asking DC to do it is because his enterprise, Tejas, actually designed this memento. So,